I will do it. Hello, good evening, everyone. Bit late today. Okay, just a minute. Let me upload my PPT. Just give me a moment. Okay, fine. So let us continue once again with the misconceptions in physics problem solving. My name is Ratankar and I teach physics for an international school for IBDP syllabus. And many students were asking me, my JE old students were asking me, we do commit some mistakes and we want to know like what are the mistakes and how do you come out of it. So towards it, I started this channel. I think by now it has almost cost. I think today is the 99th video that I am uploading it across. So tomorrow will be the 100th one. Now let us start with this. And it has been received wide attention by many people, many faculty members, many students from various disciplines are all part of this. I hope this will continue further. Okay, now let us start with this. So we have done several problems on mechanics, kinematics, dynamics. Then we have done on work, power, energy, and so on. And now we are into the rotation chapter. In fact, rotation chapter is considered to be one of the most toughest chapter for all those preparing for the competitive exams. And many of them do commit mistakes. And most of the questions in IIT do come from this particular chapter because they feel if you are able to solve problems in this chapter, then definitely you should be able to do any problems from the entire uh, list of mechanics, or your fundamentals are very strong. So that's why I think maybe rotation is being asked. This is a common portions for CBSE, ICSE, IGCSE, and ATEXL. Of course, in IBDP, we do not have this, but the rest of the streams do study this into detail. Okay, so towards it, I have seen while I correct the papers, I have seen okay several students making mistakes. I have pointed out all those, made a note of all those, and that's what I will be discussing over here. Or maybe when I ask some questions in the class, some students give me incorrect answers because of the concepts that they have understood incorrectly. So now we will be doing one of the problems here. So far, 11 problems has been done. I think most probably in rotation itself, I may go to another 8 more problems around 20. Hey, tomorrow I may not be available online. I will not be coming online because of heavy work at school. So after coming back, also Friday. So I haven't recorded the new lectures. Even now, also it will be a bit late once I start uploading it. Anyways, let me try my best. At least by night 9 p.m. possible, I would try to upload one and schedule it for tomorrow. If not, let us see on Saturday. Tomorrow is my 100th lecture. Okay, so towards it. So spinning disk introduces a horizontal velocity. Now the problem is something like this. Once I took my students to the field and we were talking about how physics plays an important role in cricket, volleyball, football, and so on. While I was doing this, I just took a tennis ball. Now I spinned this in this direction. There's a cement floor here. Now as it spinned, it came spinning. I just dropped it. So it started spinning. When it came here, it fell down here. Okay, and then it started bouncing back. Okay, so it was spinning here like this. It started bouncing back. When it bounced back, now I asked him as an MCQ, or maybe not even MCQ, just practically. Now, before I dropped it, I asked him, the moment it falls here and bounces back, what would be the center of mass velocity? So the same problem I have coined here. What would be its center of mass velocity? And many students said, okay, initially, if the center of mass velocity is like this, while bouncing back also, it should be like this. And then I also asked them what could be its angular velocity. The angular velocity, as you see, it's like this. It's this. So rotation is like this. So now when it hits here, it's reversing its motion. So angular velocity might be like this. This is what is the answer I got. Okay. Why? Just once again, a misconception. Why do students make this mistake? The reason is because they have not understood clearly friction and rotation. You understand friction when the particle is sliding, but when the particle is rolling, what happens to the friction? That we need to know. Now, when I take a rolling ball, if I roll it like this, now this is my floor. I gently, as it starts rolling, I just place it gently on the floor. Now, what happens to this rolling ball is the first question I should ask. So as a result of it, if it is rolling like this, will it move in this direction or will it move in this direction? Which direction do you think will it move? Now, when I roll it across, I don't have a ball with me. Otherwise, I would have shown you. So when I roll it across, now this starts moving like this and it moves towards you, right? If it's rolling in this direction, it starts moving like this. You can take a ball if you have with you and you can try it out with it. You roll it, it won't move in the forward direction. It will now try to move in this direction. Now, the question is, see, you rolled it like this. You spinned it in this way. Okay. Maybe I can show it here. Yeah, I can show it with this pen itself. Wow. For me, whatever I see here is my lab. I have my background. Oh my God, I'm not able to show you this. I'll just remove my background initially for some time. Then, how do I remove it? I am not able to see the cursor also. Oh, just a moment. I need to remove my background and choose virtual background. Yeah. How do I remove it? Just a moment. Yeah. Okay. So I hope now it is seen. Now this is the pen that I have. And what I do is I'm spinning it in this way. I'm spinning it in this way. And I'm leaving it. Okay. The moment I spin and leave, look at it. Okay. How am I spinning? I'm spinning it in this direction. Okay. In this direction. So when I spin it and leave it, just a minute. It fell down. Got it once again. So I'm spinning it here and I'm leaving it. It started moving towards you, right? Once again, if you want, you can see. See, I'm spinning it like this, right? I'm spinning it like this. In the way how it is spinning like this, okay, it moves towards you. Moves like this over. If I spin it like this, in the opposite direction, so if I'm spinning it like this, right? I'm spinning it like this. Sorry. If I spin it like this, you see, it moves towards me. Okay. So this makes us clear that whenever we spin it in a particular manner, then it moves according to it. Okay. Now, just a minute. Yeah. Okay. Fine. I'm done. Right. So therefore, when I spin it like this, I should expect this particle to move like this. That's what it happens. Okay. Now what happens to center of mass velocity? Okay. Now let us look at the problem correctly. Let me go to the next slide to know more about it. Now, what did we do? We have a ball or a disc. Here we have used a disc. I used a ball there. Okay. Now we spin this disc. It falls onto it. When it comes here, this is its angular velocity. Now, where is the friction acting? That's the question I need to address. Center of mass is here. Where is the friction acting? The friction should now act like this. Many of them will say, how can it act like this, sir? Because, friction should always act like this. If a particle is moving in this direction, friction will be acting in the opposite direction. Now, where is the particle moving? Now, to understand this, friction, okay, so when you say, where is the particle moving? Particle is moving vertically downwards. So in that case, how do you attribute a direction to it? That's the biggest question I have. Okay, so now what we do is, let me zoom into it. When I zoom into it, what will I say? This point, okay, let me call this point as point A. This point A. The point A touches here. Now, can you tell me what is the what is the direction of point A? If the ball rotates like this, the direction of point A is in this direction. Okay, of course, it doesn't go like this, but it goes upwards. But if I write a tangent here, direction of this point A is in this direction. Now, if that is the case, where should friction act? Friction should say, see, I am not going to let any of the particles on your disk to go in this direction. I'm going to oppose it, right? Because friction is nothing but it's a force that opposes the relative motion between the two objects. Very, very important definition. If you want, I will write it down. Friction is the force that opposes the relative motion between two objects. It's a relative motion opposing the relative motion between the two objects. So therefore, if this is the velocity, angular velocity like this, then this particle is now going like this. Now between these two surfaces, it should opposite force. So it should act like this. Now if there is a force acting like this, what will happen to the center of mass over here? Now the angular velocity will slow down. The spinning action will slow down, definitely, because it will not spin with the same angular velocity. But there will be a center of mass. So this center of mass will now experience a velocity like this. Okay, it will experience a velocity like this. Now there are two motions here. The first motion is the ball is falling down. So as a result of it, normal force will now throw it like this. Okay, we'll give an opposite force in this direction. Then the frictional force is now acting here. Now what will happen to the ball? The ball will not go like this, but instead it will go like this, right? It will now describe projectile motion like this. This is what should happen. Got it? So we usually see what we do is the moment a problem like this is given, we think, okay, it should be like this. But practically, when you see this, you take a ball, you throw it across, you drop it across in a similar way, what you do, and definitely you'll be able to observe, right? Thank you, friends. That's the solution. Okay. There's nothing more about it. So I'm not asking you to compute anything over here because I'm not giving you any parameter over here. I just given omega naught over here. It's released from a certain height. You can assume, you can find out what is omega naught, what is v naught, and so on. But the interest here is not math. The interest here is only about understanding the concept correctly. Okay. I hope you have understood the concept about how to analyze friction when it comes to rotation. Okay. Thank you, friends, for watching this video. If you like this video, do share and subscribe to my channel for more updates. And you can also write back to me about what kind of problems would you like to discuss. And don't write me. See, some of them have written, can you explain Newton's third law, Newton's second law, and so on. I'm not going to do this strictly. The reason is because Newton's second law and third law, you can find out in every textbook. There's nothing new about it. But if at all, if you find that there is a problem and you need to, you have attempted it in a given way, but somewhere in the exam, your teacher or your faculty member had said, okay, that this is incorrect. Okay, but still you are not able to understand why was this incorrect, where did I go wrong at that moment. Okay, when you solve a paper, at that moment you will be able to understand. But when you come out of the classroom, you will feel, hey, I did everything correctly, but still I got incorrect. When I'm giving you the same question once again you will have a problem with. Okay, that should not be met. Okay, so towards this only, this channel has been set up. Thank you for watching this video. Do like, share, and subscribe to my channel for more updates of this sort. Thank you, friends.